Yeah, thank you so much for having me, Peter, and I really appreciate it. I'm going to be talking about JSON Web Tokens, or JWTs, or JWTs, as they're called. And real quick housekeeping, I really like for this to be a conversation rather than me just talking at you for 45 minutes, as Peter mentioned. So I do have the chat window open, and I will be looking at that for questions. So if you hear me say something that seems outrageous, or you have a question about an aspect of it that I talked about, that would be great if you just drop that in there. I may not answer it right away, but I will answer it. And Peter mentioned the giveaway. I'll show you pictures of those actually right now. This is the t-shirt, which we can ship to any place in the US or Canada. So that's, sorry, the person from Argentina, I won't be able to ship it to the end of the earth. And then we also have this ebook, which is about 80 pages about OAuth. And if that doesn't put you to sleep and that excites you, you can win that as well. So I'm going to pick 2 people randomly from the people who ask questions. And as long as you meet those qualifications, which the ebook I can send anywhere, then I will happily get you those giveaways. All right, so let's go ahead and kind of get going. And I'm going to talk real briefly. I promise this is not a vendorware talk. This is the only slide about FusionAuth. We're basically similar to Auth0. We're an authentication and authorization platform. We support OAuth, OIDC, SAML v2, LDAP in some ways, not in other ways. I can talk about that if you want. And basically, we're a drop-in architectural component that takes care of authentication and authorization and user management. So you would never build an entire application on FusionAuth, but any application could use something like FusionAuth. And we're a little bit different than something like Auth0 because we are usable either as a SaaS offering or self-hosted. And I can talk more about that if you want, but let's move on to every audience's favorite slide, the About Me slide. Who cares? You can look me up on Twitter. You can look up Meetup when it stops 403ing. You didn't come here to learn about Dan. You came here to learn about JSON Web Tokens. So here is the agenda. We're going to talk about JSON Web Tokens in brief. We're going to talk about the problem they solve and some of the different ways of approaching that problem. We'll talk about how you should validate JSON Web Tokens, because that's a very important thing you need to do every time you get a JSON Web Token. We'll talk about some of the issues around bearer tokens and how you should store them, which is a superset of bearer tokens are basically a superset of JSON Web Tokens. We'll talk about some common issues that I've seen and some of our users and customers have run into. We're going to cover the refresh token grant, which strictly speaking isn't a JSON Web Token thing, but it's closely related. So we're going to spend some time on that. And then finally, we'll talk about JSON Web Token revocation. And again, questions, you can save them to the end. You can put them in the chat, whatever you want to do. So let's talk about JSON Web Tokens briefly. JSON Web Token stands, JWT stands for JSON Web Token. It's basically a bit of JSON that gets wrapped up and can be passed around among other pieces of software. It's actually pronounced JWT, according to the standard. The IETF made the rules, not making that up. It is defined in 7519, and it's actually, there's a set of JSON Web Token related RFCs. 7519 is where the signed JSON Web Token spec is outlined. It's only about 10 or 12 pages. And when I say signed, there's 2 main categories of JWTs. There are JWTs that are signed, where you take the content and you run it through a cryptographic algorithm, and it could be a symmetric one or an asymmetric one. And we'll talk a little bit about that difference in a number of slides. But you end up with a signature that is based fundamentally on, it's kind of a hash based on the contents of the JWT. And so anyone else who has the contents of the JWT can calculate that same signature, and they can verify if the contents were changed. Now, anyone can read the contents if it's a signed JWT, but no one can change the contents if anyone checks the signature. An encrypted JWT is a different thing, where the content is actually, it's typically encrypted then signed, and the payload that's encrypted no one can actually see unless they have the decryption key. Now, a lot signed JWTs are a lot more common, so that's what I'm going to focus on. But it is important to note that there are those two different things, two different options, and that with signed JWTs you have integrity guarantees, and with encrypted JWTs you have integrity and secrecy guarantees. The main context in which FusionAuth sees JWTs, and it's a pretty common one, is they're stateless portable tokens of identity. What does that mean? Let me take that apart a little bit. They're stateless in that you can verify the validity of a JWT without contacting any external server. So the JWT carries within itself enough information that you can verify the integrity of it, that the contents were unchanged, and then you can take actions on that without calling out to any central server. They're portable because they basically get base64 URL encoded, which means you can put them in cookies, you can put them in query parameters, although that typically is a bad idea. You can put them in form posts, you can put them in HTTP headers. So they're really HTTP friendly. That's what I mean by portable. And then tokens of identity, typically what we see JWTs used for, and certainly what FusionAuth issues them for, is they are basically information about a principal. Someone's logged in and we want to know who they are and what they can do and some other attributes about them. And that can all get wrapped up into a JSON web token. Because they're stateless, because they're portable, because they represent an identity, they're great for APIs and microservices because you can have one server issue them and then they can get held by a client and passed around all over the place. And all the microservices and APIs can validate that JWT, that caller identity, without ever talking to that server that issued the JSON web token. They've been around. 7519, was issued in 2017, I want to say, is when it got finalized. And so they're pretty well standardized, and a lot of identity providers issue them, right? I've already mentioned FusionAuth does it. I know Auth0, Okta, Ping, some of the newer auth players, they all build JSON web tokens for the reasons that we talked about above, right? It's well understood. There's a lot of supporting libraries out there. It has some flexibility because you can put other things into it, right? It's a JSON object, so you can put custom parameters in there. And in addition to the libraries and documentation and the identity provider support, there's just a body of knowledge around JSON web tokens. There are some competitors, and JSON web tokens, by no means, like any engineering tool, are not a panacea, but I think that they solve a lot of problems pretty well. So let's talk about the problem that they actually solve. And I'm going to walk through kind of 3 scenarios. And the first scenario, please don't ever do it. And then the later scenarios, it's kind of 2 different approaches to solving a problem. Let's look at this problem. The problem is, here we have a vastly over-engineered to-do application. We have our clients over there on the left. We have a couple of different APIs with their own data stores. One is a user API, one is a to-do API. The user API has normal user things in it, right? A users table, a roles table, and then a mapping between the two. And the to-do API, the data store just has to-dos, because this is a microservices architecture, so the data store is not shared. Maybe it's not microservices, it could be just service oriented. The to-dos table, if this is a relational database, looks like this. There might be more information about whether it's done or not. One thing that's worth noting is the user ID is not a foreign key, because again, these are separate data stores, so we can't have a foreign key into the users table. So it's just a string. So when we want people to be able to look at their to-dos on one of the clients, right, to be able to add, hey, Dan's going to speak at SF Jug, Dan's going to go pick up groceries tomorrow afternoon, whatever my tasks are, first I have to log in. And I'm going to log into the user API. I'm going to present some kind of credentials, and then I'm going to get some data back. So let's take a look at the solution. First, we post we post to the user API, and it's going to check the credentials somehow. And we really don't care for the purposes of JSON Web Tokens. That is like a bit of magic. We don't really care how that happens. Somehow I'm verified, right? Typically username and password, but it could be something else. And then my data is pulled from the users table, and then it's passed back down to the client as JSON. And that JSON might look a little bit something like this, right? We have an identifier, we have a name, we have my email address, particular roles that I might have inside this application. And this could be something else, right? This is a demo application, but you could take more attributes of the user and pass them down to the client. The client then needs to find my to-dos. And to do so, it needs to actually peel off my user ID, and then it's going to pass that to the to-do API. And the to-do API is going to look that up in the to-dos database and pass back JSON. And then the client can render the JSON. And I've kind of already buried the lead. This is not a good idea. This is a bad idea because there is a malicious client can go ahead and look at that request that I'm making against the to-dos API and notice that I get passed that I pass in a user ID, and then it can go ahead and ask for anybody else's to-dos. And so it could, and it also knows that there are at least 42 users in the system. So you're leaking data about the system as well. And, I definitely want my tasks of going to the grocery store tomorrow to remain, safe and secure if I'm going to build a to-do application. So let's talk about a different approach. So in this approach, instead of passing back the user ID and having the client peel off the user ID and pass that to the to-do API, we issue a token. And this token is some random string. It just needs to be high entropy. It just needs to be something that a malicious client can't guess. And it can be included in the user object that's passed back. And so that user object includes the token. The client knows enough to take the token out of the user object and pass that to the to-do API. At this point, the to-do API doesn't know what to do with this. It can't use that token as a foreign key into to-dos, because if it did, then you'd run into the same enumeration problem, right? Where a malicious client could just pass various strings of a token into the to-do API to try to get other people's to-dos. So what it does instead is it says, hey, I have this token. I'm going to pass this back to the user API. And the user API can know if it issued that token. And if it did, it says, oh, yeah, I recognize this token, and this is a valid session. This person just authenticated. I'm going to hand back the user data. And then from there, because the to-do API trusts the user API, it can take off that identifier and look up the to-dos in the database. If, on the other hand, the token is invalid because a bad client is trying to, enumerate tokens or just probing the to-do API, then the user API will return back nothing, and the to-do API can return a 403 or whatever it wants to return. So this is what we call the opaque token approach. And this is actually part of the OAuth specification, or part of the OAuth family of specifications. It's introspection. And it is an absolutely valid approach. It does have some trade-offs. You have to maintain a user token mapping on the user API side, right? This right here, the user API needs to know if a token is valid or not. It can be chatty, and every time a request comes in with a token, which is every request, pretty much, then the to-do API and every other API needs to call into the user API to make sure that token is valid, which means that you couple everything to the user API. So if the user API goes down, or it's slow to respond, or has downtime because it's getting upgraded, you're going to have issues. So this is where JWTs offer a different set of trade-offs. So with a JWT, the user, again, the user logs in, right, against the user API using those credentials, that magic transaction that we don't really care about right now. the JSON Web Token gets created and issued, gets passed down to the client stores it. Again, this is very similar to the way the opaque token was used. The JWT is presented to the to-do API, and the to-do API can examine that JSON Web Token, validate it without ever talking to the user API, and then pull the information from the to-dos table. Because the JWT is, as I mentioned earlier, self-contained. So JWTs can be signed, and they can be signed either with a public-private key pair, and we'll talk about that in a little bit, or a symmetric key. The big win is that you can validate them without calling the user API. And you can imagine with this example, there's only 2 servers, only 2 APIs, not a big deal. But if you have tens or hundreds of APIs, not having to scale up the user API to validate that token could be very helpful. The other nice thing about JSON Web Tokens is because they're JSON, they can contain roles and other metadata. So you can put in whatever you want as long as you're okay with it being viewed by anyone who gets a hold of that JSON Web Token. And that can be helpful as opposed to the opaque token, which is really just a kind of a random string. So Andrew just asked a question: what objects can be in a JSON Web Token? A picture, a puzzle? Is the token a compromise between simplicity and security? So let me take the first part of your question, which is anything that can be represented in JSON can be put into a JWT. If you Google how long can a JWT be, you'll find a Stack Overflow question which talks about the length of an HTTP header. I have not found anything in the specifications or anytime I've given this talk, and I've given this talk probably 30 times, where anyone has proved to me that there's a limit on the JSON Web Token length. Where there is a limit is in the transport layer. So if you're putting it into an HTTP header, you have HTTP header limitations. If you're putting it into a cookie, you have cookie limitations. If you're putting it into a form parameter and you make it a very big thing, a meg in size, then it's going to be a slow form to post. But it's not intrinsic in the JWT. The largest JWT I've ever seen was actually a JWT that was data about a particular web technology and the devices that implemented it. It's called FIDO2 or WebAuthn, and there's a JWT that is on the FIDO Alliance website that is like, I want to say it's it was a gig in size. No, maybe it was just a couple of meg. Geez, I don't remember. Sorry, that was a horrible anecdote. I'll have to dig that up, but it was big. It had 1,000 devices in it and just a ton of metadata, and it was a huge old JWT. So the second question is the token a compromise between simplicity and security? And I'm not sure I understand that question, Andrew. I think that the trade-offs for the token, the main trade-offs to think about are, do you want something that is standalone and therefore has their issues around revocation? And we're going to talk about that at the very end. Or do you want something where you have to call back to that user API repeatedly? That's kind of the major architectural trade-off, I'd say, with JWTs. Mauricio asks, how can you invalidate a token that was compromised? Is there an expiration for it? I'm going to pause that. Can you ask that question towards the end of this? Because I'm going to talk about expiration. I'm going to talk about validation. I'm going to talk about revocation, but those are all later slides. Cool. Sarete says, I might have missed this, but does the JWT get shared directly between the user API and the to-dos API? That's a great question. Let's go look at this. So in this architecture, the user API issues it and the client holds it, and then the client presents it to the to-do API. Now, you can use JWTs any which way you want, right? They're just a data transfer mechanism. They're a way of wrapping up data and turning it into something that's HTTP friendly. So you could use it to move, to transfer data between services if you wanted. But in this particular architecture, the client holds the JWT, and the client gets it because the user has authenticated and the user API has issued a signed JWT. Great. All right. So let's talk about, so enough waving my hands and architecture diagrams. Let's actually look at some real JWTs. So this is a real live JWT. This is a signed JWT. Remember, I talked about encrypted JWTs and signed JWTs, and I'm going to focus on signed JWTs. Every signed JWT has 3 parts. There's the header, which is in green, the payload, which is in blue, and then the signature, which is in that tan or that white. So both the header and the payload are base64 URL encoded JSON. So here's the header, right? And this just has metadata about the JWT. So you could cut and paste this and put it into any base64 decoder, and you would get back this JSON object. And so this has things like which algorithm was used to sign it, what the type of JWT is, because there's multiple different types of JWTs, and then other information. The payload is where things get really interesting. And so this is, again, a JSON object that is turned into a URL and a base64 URL encoded string. And the keys of the JSON object are called claims. And I don't know why they do this. Identity people like a lot of jargon, but the claims are just the keys. And there are two major categories of claims. The first is the ones that are defined in the RFC, and that's the first four here. And so the ones that are defined in the RFC have their semantic meaning defined. What does that mean? That means that you can roughly, if you get a JWT from FusionAuth and a JWT from Auth0 and a JWT from Okta, and they all have the ISS claim, you can roughly know if they're standards compliant, what that means. And what that means in particular is who issued the JWT. So in this particular case, FusionAuth, some server called FusionAuth issued the JWT. I've seen that be a domain name like it is here. I've seen it be a string. I've seen it be a UUID. I've seen it be a URL. It doesn't matter what the actual contents are, as long as both the issuer, right, the user API, and the consumer, the two API, understand and agree on the same thing, right? It doesn't matter whether it's a domain name or a URL, as long as both parties understand what should be there. The other thing to note about this is that you can have, the other major category of claims are the non-standardized claims. And some of these are have kind of common understandings, but others of them are totally custom. So you can put whatever you want in this JSON object, and as the roles claim shows, it can actually be an object or an array. So you could have a claim that's an array of objects of arrays if you wanted. You can nest them. Anything that can be represented as a JSON object can be turned into a JWT. Finally, the last part of a JWT is the signature. And the signature is basically, as I mentioned earlier, you take the header and the body and you run them through a cryptographic operation, and then you turn them in, and then you turn that generated hash essentially into a something that can be your URL or base64 URL encoded, and then you attach that to the end. And the operation does vary depending on whether it's a symmetric or asymmetric algorithm. So this is a good time to pause if there are any questions about what we talked about in terms of kind of the nuts and bolts of a JWT, or why you might consider using a JWT in your system. Any questions? I need to have the Jeopardy music so I can play that. Okay. Well, again, please keep asking questions in the chat. Okay, so now we're going to talk about how to validate the JWT. And this is something that is the responsibility of the to-do API in our system, or any other APIs that get a JWT as a means of the client proving who they are. So the first thing you need to do is validate the signature. And my best advice there is to use a library, because validating the signature is a complicated thing, and it's easy to get wrong. And there are lots of libraries out there. There are many open source libraries. We have our own FusionAuth-JWT, but I know there are others out there too. So, you know, if they're in the business of like consuming a JWT, make sure you validate, use a library. It's just going to save you a lot of time. And if you get a JSON Web Token that the signature does not match what you expect it to match, what the library expects, stop processing, right? That is just the same as if you got a password that was invalid or you got an API key that was incorrect. It basically means that somebody's doing some funny business. Either it's a bug or it's somebody attacking the system. So don't process any further. So Dimitri says, if base64 is the only obfuscation, is it not dangerous for malicious client? So Dimitri, that is a great question. And the answer is the power of the signature, right? The signature means that you can trust, if the signature matches, that it was created by someone that you trust. And so you can trust the contents of it, therefore. Now, a malicious client can look at it and see stuff. And so that if that's a danger to your system, then maybe an encrypted JWT is a good option, or maybe you need to like change what you're putting into the JSON Web Token. But if you get a JWT and the signature validates, then you can be sure that it was created by someone who had the key that corresponds to the signature. Yep. So let's talk about validating the claims, because there's two parts to any JWT validation. The first is a signature, but you can't just stop with that, because the signature just says, hey, this was signed by somebody that I know. But the other things you need to look at are the claims. And this is really business logic, because it depends on what the JWT has in its claims. And it's not something that a library can help you with. There's some libraries that help you with some of the standard claims, but really it's something that you're going to want to look at. So you have to write this. And this is a really good candidate for like a shared library or shared class, but you have to write this, because you're the only one who knows what claims are going into your JWT. So you need to make sure you understand what claims you're expecting. So there are 3 claims that you should check every time. The first is the issuer. And again, this is who created the JWT. You just want to make sure that you know who it is. You don't want to just accept JWTs willy-nilly unless you know who created them. This is, in this scenario, the user API is the issuer. The second is the expiration time. And this is the number of seconds since the Unix epoch. And basically, if this time is and it's UTC, if this time is in the future, then this JWT is valid. If this time is in the past, then the JWT is not valid and you should just stop processing. There's another time-based claim called NBF, which basically stands for not before. And so it's possible, if you want to issue a JWT that's good for, a year from now to a year and 5 minutes from now. You can absolutely do that. And if you see the NBF claim, you should check that too. That's less common, but it's definitely possible. The next claim that you should check is called the AUD claim, or for audience. And this could be a string like it is here, or it could be an array of strings. And this is, in our scenario, the to-do API. This is who this JWT was issued for. So we have the issuer claim, the ISS claim, which is who the JWT was issued by, and then the audience claim is who this was issued for. Why is that important? Well, you could imagine the user API might authenticate for a number of different APIs, and you could imagine that someone might have a role of admin in the to-do API, but not the role of admin in the accounting API. And obviously, if someone got a JWT for the to-do API that gave them a role of admin, and then presented that to the accounting API, and the accounting API didn't check the AUD claim, then you might get elevated access or possibly just trigger a bug, right? So you definitely want to know who this JWT is for and check that out. So let's look at a brief bit of code. And this is an open source, just a small example project that I have, and the links are in the slides, and I can make that available to you. But here is some Java code. And basically from lines 18 to lines 38, we're pretending this is the user API, right? So this is a very simplified example. This is basically, instead of having 2 different architectural components, I have both components kind of stuffed into one class. but this at least gives you something to play around with. And so I am creating a JSON Web Token. I'm issuing it at a certain time on line 25. I am setting a subject. I'm setting expiration time. I'm putting in some other claims. Let's put in awesome presenter. There's no maybe, so I guess I'm gonna have to go with true. And then we're basically signing the JSON Web Token, and we're gonna print it out on line 38. And then on line 44 on, this is the to-do API. So on line 45, we have a verifier, and you should see that on line 21, the secret. So this, in this particular case, we have a shared secret. I'm going to talk a little bit about that in a little bit, but on line 21, we are signing it with a secret of not enough many secrets, which is a weird thing to say. Let's change it to not enough secrets. And then here, we're going to change it to not enough secrets. So we have the same secret that we're signing it with. We're also going to verify it with. We also are doing some claims checking here. Line 47, 48, we're checking the issuer, we're checking the audience, and then we are going to decode it on line 51, and that checks the signature for us. And then on line 52, we're doing the business logic to check the claims. So I'm going to go ahead and save this, and I'm going to run it once with the where everything checks out, and we'll see both the JSON Web Token printed out on line 38 and also the on line 56, we're printing out the decoded version, and then I'll change it so that it fails, and then we'll see the exception. Good old Maven. So yeah, so here's the JSON Web Token, right? And again, this is very portable. We can put this into a cookie or anything else. We can pass it around. And here is the values that it was encoded to create. Let's go ahead and change this so that we're actually expecting an issuer of HTTPS. And this now should fail on line 53. So there are, it fails, line 53, because the claims didn't match. So I have a few other examples in here. Again, the URL is in the presentation, and this obviously is super simplistic, but this at least gives you an idea to like play around with the different ways, different things you can put into a JSON Web Token, the different ways you should validate a claim. All right, so let's kind of move on to bearer tokens. Oh, actually, so Dimitri asks, at what point is the issuer being contacted, if at all? The issuer is contacted when the JWT is created, and then at that point, you need to contact it. There needs to be some way to transmit the shared secret if you have a shared secret, or the public key if you're doing asymmetric encryption or asymmetric signing. But apart from that, you shouldn't need to. That's one of the wins of JWT, is that you can have 100 different services that are all consuming a JSON Web Token that's issued by the user API that don't have to talk to the user API to validate it. Any other questions right now while we're kind of at a pause? Okay, great. So let's talk about bearer tokens. And bearer tokens are a bigger subject than just JSON Web Tokens, but JWTs are often used as bearer tokens, so it's worthwhile to kind of throw in some information about them. The idea with a bearer token is that a bearer token is very similar to a car key, right? If I have my car key and I hop in the car and turn on the car key, turn on the car starts. If I give it to my neighbor, they can do the same thing. If somebody steals my car key, they can do the same thing. So holding the key is enough to give me access to the resource, which in this case is the car. So the reason you need to be careful of bearer tokens is that if a bad actor gets a bearer token and presents it to the to-do API, the to-do API is going to do that same validation, but it doesn't know that the client that presented it is someone who stole the token. So it's going to go ahead and give them my to-dos. There are solutions out there that tie the token to the client, typically cryptographically, but they're not, as far as I've seen, not commonly deployed and not easy to do. But I can definitely give you some names if you're working on a system where this kind of threat model would be unacceptable. So what we typically say is store your tokens carefully, keep the expiration small, and that's worked for a lot of our clients. They don't need to go to that next level of tying the client to the token. So as far as storing the token, you can either do it server side, which kind of takes a whole set of class of problems off of you, right? Because you can store it in the session. The issue there is that now you have a lot more insight into how that token's being used, but now you have a sticky session, right? And so every client has to have its session. You have issues with horizontal scalability. But you can run everything through one server that holds that token for your users and then pass that token around to other APIs if it needs to. Another common pattern we see is you push that token down as an HTTP only secure cookie in the browser, and therefore it's much harder for someone to steal the token and pass it off to some other server in a different country where they can suck down all the to-dos. The same, basically an analogous thing on a mobile device is to store it in secure storage, right? The iOS keychain or Android's secure storage. And actually, I should put another slide here. If you are interested in that client side coupling, right, where we have a token that gets tied to a client cryptographically, you want to do research on, it's called Depop, which is an upcoming standard. I don't think it's been through the full IETF process, but there are definitely people who are implementing it, or MTLS. Those are kind of the two ways to do that, kind of bind that token to the client. So let's talk about some common issues that we've seen people run into with JSON Web Tokens. First is they don't do validation correctly, right? They don't use a library. They try to validate the signature themselves. They don't check the claims fully, or they just rely on the library to check the claims. And most libraries will check the expiration time, but they won't check those other audience or issuer claims or anything else that you need to check, right? You may need to check roles. You may need to check whether they're a premium user or not. And that's all business logic that you need to write. Another issue, and this gets to some of what some of the questions have been, is you don't want to put a secret in a JWT. You never want to put like a social security number or anything that is, that if somebody saw the JWT, it would leak information. Because with a signed JWT, and again, encrypted JWTs are a totally different ballgame, but with a signed JWT, the integrity is guaranteed, but secrecy is not. So you might have noticed that the JWT that we had, that I showed you, was the subject was a UUID. And I've actually seen JWTs where the subject is, sorry, I didn't tell you what the subject claim was. The subject claim basically is the identifier of the person that the JWT is about. But if you have any integers in a JWT and somebody else looks at that JWT, they can make assumptions about that integer, right? Like if you have a subject and the identifier is 1,000,001, then somebody can reasonably surmise that that system has 1,000,000 users, which may be information you don't want to leak. So think about what you're putting in your JWT, and sometimes it may be as little as a UUID that you can do lookups on later. You just want to make sure you don't put any secrets in, for sure. If you use the HMAC algorithm, which is the symmetric signing key, that's the one I showed you. That is this one, right? This is a horrible, horrible key. You know, that is not a lot of entropy. And there is a piece of open source software out there that can take just a JSON Web Token that's signed with an HMAC algorithm, and it will try to brute force it so it can get that key value. So you want your key to be nice and long, 100 characters, lots of entropy, random string. Otherwise, you can have someone discover your key via using a tool like this. And if this attacker discovers your key, right, they can crack your key, then they can now issue JWTs that look just like they're issued by your user API. And obviously that's a horrible idea because they can put whatever they want into the payload, right? Oh, this person has a role of super admin, or this person has a subject ID of somebody that of one of the admins, or this is an audience for the accounting API. They can put that into the JSON and they can sign it, and that signature will verify because it's the same source key. So be careful when you're using HMAC. Another thing that that JWTs get a lot of grief about is the none algorithm, which is basically there's no signature. That means that there's no integrity check. Basically, this is a valid JSON Web Token, right? We have the header, we have the payload, we don't have a signature, but it's still valid. And that basically means that anybody who discovers an API that accepts a JWT that has algorithm none is basically open for business, right? Anybody can create any JWT and sign sign it, or they don't even have to sign it, right? They just create the JWT, they base64 encode it, and they pass it to your API, and your API says, "Oh, this looks fine, doesn't have a signature, I don't care." And that's really kind of unsanitized credentials, which is really, it's worse than unsanitized user input. Now, there are scenarios where none makes sense. They're few and far between. An example might be where you're using JWTs to pass around information, but you're on an isolated network. And you've also benchmarked and know that the signing process takes enough time that it's material for your system. It's pretty rare, and my guess is you're not going to be attending an SF Jug meetup about an intro to JWTs if you're in that scenario. Let's talk about asymmetric key pairs now. Actually, let's pause. Any questions right now? Thank you. All right, no questions. Great. Thank you, Peter. That was awesome. All right, so let's talk about asymmetric key pairs and asymmetric signing. So in this scenario that we've kind of talked about before, basically the JWT is issued by the user API and is signed using some string as a key. And then it's passed the client. The client doesn't have access to that string, but it's passed back to the to-do API, and that to-do API needs access to that string to validate that the JWT was signed correctly. And that is, again, that's what we saw in the example code. And that secret being in both places, again, it could work really well for your system if you have a way to distribute secrets. If the user API and the to API are both managed by the same team, right? If it's a small team, then that can work pretty well. But asymmetric key pairs avoid having to have that shared secret. And how that works is the private key signs the JWT and the public key verifies it. So this is helpful because you can actually have a lot more scale, right? You can have the user API owned by one team and then all the other APIs built by different teams. So you can scale up to a much larger number of teams because you don't have this distribution problem of the shared secret. And the other thing that's really great about it too is obviously it's more secure because anyone who has that shared secret can sign keys the same that are indistinguishable from those that are created by the user API. So here's an example of the scale option, right? Like we have the Pied Piper organization, which manages the user API and it holds that private key and it takes care of the user authentication, and then it signs the JWT. and then that gets passed to the client. The client passes back to the to-do API, which is created by the Huli organization. And there, again, there could be 1, 10, 100 different to-do API type of things, right? Or not to-do API type of things, separate APIs that are all managed by totally different teams. And they can all be validated using the public key that the user API publishes that corresponds to the private key that was used to sign the job. And then as far as the security goes, again, if you have a shared secret and someone else gets that shared secret because they attack the to-do API, then now they can issue JWTs that are indistinguishable from those that are created by the user API, which means now you, if you're using a symmetric key solution, you have to secure the user API and the to-do API at the same level. If you're using an asymmetric situation, right, then Pied Piper can be super, super secure about the user API in terms of network access, in terms of admin access, in terms of the code and the versions that they use. But the to-do API has relaxed security controls because it's just taking a public key, right? And the public key is by definition public. So you might say, well, why wouldn't everyone use asymmetric keys? Well, it's a little bit slower. And again, I always encourage people to benchmark to see if that's a key thing for their system, because I bet most systems that use JSON Web Tokens are going to have bigger issues with like database latency and network latency. But it is true that asymmetric key signing is slower. Signing and verifying is slower. And I did ran some benchmarks in a different language, and it was between 2 and 12 times slower, depending on the operation and the algorithm. And so it's just more complex. Part of the complexity is you have to share the public keys, and you have to do that somehow, right? The same way that you had to distribute the shared secret to different servers, you have to have some way of getting that public key to the to-do API. So this to-do API absolutely is going to need the public key from the user API to validate the JWT. Remember, the pattern is the user authenticates, the user API generates the JWT, signs it with the private key, passes the client presents it to the to-do API. The to-do API needs to validate both the signature and the claims. To validate the signature, it needs to have the public key that corresponds to the private key that was used to sign the user API. So the first thing you can do is you can distribute the keys at deployment, right? And so this public key, you could put in 100 public keys into the to-do API, and then each public key would correspond to a private key, and you'd have some kind of mapping between them. And that is actually a particular claim in the header. We'll see that in a little bit. But the idea here is that the public key is part of the to-do API. It's on the file system, and the to-do API knows how to look that up. And the nice thing about this option is that there doesn't need to be any network access at all, right? The user API could be 100% down, could be offline, could be in a disjoint network, and the to-do API would still be able to validate that JWT. The downside, of course, is that you might run out of public keys if the user API rotates keys. So Saret asks, does each API call need to be validated? And is there overhead in validation? Yes, because this is a stateless thing, but because this is stateless, you need to validate the claims and you need to validate the signature. Each JWT could be different. I suppose if you're really, we have not run into systems where the validation overhead is enough to be concerned. I guess there are probably ways you could go around that. You could take a hash of the JWT and throw that into a cache. And if you've seen that hash before, and it was valid there, you could do a lookup, but typically it's not that much overhead. So the other option to share public keys is what's called JWKS, which is JSON Web Key. I'm not sure.
Store,
yes. Thank you.
I could be wrong about that. I'm totally making that up. It just seems logical.
I think that is what it is, because it's basically like a list of JWTs, the keys that lives at a known location.
Maybe it's
So
service. Who knows? Maybe
yeah,
it's service or something. I'll look it up while we're talking.
yeah. It's RFC 7517. I have that at least down. But the idea is that the do API will periodically pull down this set of keys from the user API. And it doesn't need to do that on every call. It can do it once a day or once an hour and cache them because they're going to change slowly. So Julio asks, what would be the best, most secure way to access the public key every time for validation? Yeah, I mean, typically people load it up into a cache, right? You could put it into memory. You could put it into a Redis or something like that if you're really concerned about it, but it's going to be pretty slow changing, right?
Isn't this where like HashiCorp Vault, kind of comes into the picture, Dan?
So HashiCorp Vault, in my understanding, and I haven't done a lot with it, is more about the private keys and kind of secrecy around it. I don't know
Uh,
that it would be stored for public keys because this this JWKS endpoint, that's
you're
public.
right. Yep, you're right. You're right.
So
Yep.
yep. I think HashiCorp Vault would be a great solution if you have a shared secret, right? Back to the shared secret one. If the user API and the do API both need that shared secret, then have them both pull it from HashiCorp Vault, and then you can do the rotation pretty easily. You can, have stuff expire, but with public private keys, it probably matters less. Oh, thank you, Peter. Jason, web key set. I should remember that. So, Julio, did I answer your question? Okay, great. Yeah, yeah. So go ahead, let's go and take a deeper look at this JWKS JSON. Here's an example of it. And this is a lot of stuff. It just basically is a way to define keys in a standardized fashion. What's important for us really is this subset. So every key has an algorithm, has a key identifier, it has a key or a public key, or actually it's a chain of public keys, right? Because you can chain public keys together. With FusionAuth, they're a chain of one, but you could definitely have more than one in certain scenarios. So this key identifier, this starts with UK0. This actually matches what comes in on the JWT. So let me repeat that. So when I get a JWT that comes in, I'm going to I'm going to see the key identifier. I'm going to look up the public key that corresponds to that. And then I'm going to use that to validate the signature. And if I don't see it in my cache locally, I can reach out to that JWKS endpoint and then pull it down. And if I don't find it, then it's a validation error. So here's the conundrum. And this is definitely something I've seen people who were helped create the JWT spec say, hey, this is kind of a little bit of a chicken and egg problem, right? You have to look at the header to get the key identifier of the JWT, right? A JWT comes into the do API. You have to look at the header to get the key identifier to get the key from the public key set to verify the signature to know if the JWT was tampered with, right? So the upshot for that is a complicated thing because basically you're looking at the header, which could have been tampered with, to get the signature to know if the JWT was tampered with. So you want to make sure, again, this is something where using library is a really good idea because that is a complicated thing because you're basically looking at unvalidated input to get a key or get a public key to verify the input. And so the libraries do it right. This has actually been the source of some attacks. So again, I just want to emphasize, as far as the signature validation goes, please use the library. So Raphael asks, are there best practices in terms of how long a JWT should be valid and whether to transfer it through HTTP headers of the body? So a JWT should be valid. Basically, that's a threat model question, right? Like, what is the risk model if someone steals your JWT? Do they get access to someone's health data? Do they get access to a bank account? Can they move stuff around? Can they move money out? Or is it more like they get access to my social network friends, right? And how am I storing that token on the client side? And how so the shorter the lifetime, the less risk there is of someone stealing it and being able to access data, but the more you have to go through the refresh token grant, which we'll talk about in a little bit. So, we typically recommend people have JWT lifetimes of seconds to minutes. And your second question is whether to transfer it through the headers of the body. I don't think that matters as much as long as you're not putting in a query string. Don't put in a query string, because if you put in a query string, it can get caught in caches, it can get logged, but headers and body both are okay. If you're doing what we recommend in terms of putting it into the cookie, then it kind of goes along for the ride. You don't actually have to do anything with it. Right? Because if you're making like a fetch call with JavaScript. Does that answer your question, Raphael? Great. All right. So let's talk about refresh tokens real quick. And I appreciate you all hanging out for a while. I know we're getting close to time. Refresh tokens are, as I mentioned earlier, JWTs are supposed to be short-lived, seconds or minutes. Refresh tokens can be longer-lived. And basically, refresh tokens are used to create new JWTs. So the reason why refresh tokens exist, and again, refresh tokens, the refresh token grant is part of OAuth 2 and is not tied to JWTs. It's just often used with JWTs. That's why I'm kind of going over this. So if you imagine a world without JWTs, without refresh tokens, but you're still using JWTs to get access to data, you have two options. The first is you can make the JWT lifetime short, right? Minutes, seconds. And then every time a JWT expires, you force the user to re-authenticate, right? They go back to the user API, they enter in their user and password again, and they have to re-authenticate. Now that's obviously a pain in the butt. The second option is you say, screw it, I'm gonna have a JWT that's good for a year. Then you have this security risk that is now prominent, because if anybody gets access to that JWT, they have a whole year to exploit it, right? They could wait for 6 months and then go ahead and just try to get access to that data that JWT protects, that to which that JWT protects. So refresh tokens solve this problem. So what we have is we have a the client has authenticated against the user API, and they have actually said, hey, I don't just want a JWT, I also want a refresh token. And so the user API generates both of those, and then the client gets them both and stores them safely. And then it passes the JWT to the to-do API, and then the to-do API passes back data, right? And so that goes on for a while, as long as that JWT is valid. And the to-do API every time, remember, is doing that whole validation step, right? They're checking that the signature matches. They're checking that the audience is correct. They're checking that the issuer is what they expect. They're checking the expiration time is correct. Eventually, the to-do API is the expiration time is going to be in the past, which means that the JWT will have expired. And that means that the to-do API will actually say, hey, no way, buddy, you're not getting my precious to-dos. Here's a 403, right? Because this JWT is no longer valid. The client with a refresh token system can catch that exception and say, well, I'm not sure what I'm supposed to do. I want this data, but I can't get it, but I do have a refresh token. So let me see if I can present that refresh token to the user API. Now, the user API knows a lot more about the user, right? They know whether they have paid their bills on time. They know if they count as locked by a customer service rep. They know if the user session is still live. They know all this, the user API knows all this information. And so the user API can look at the refresh token and say, oh yeah, this user is good. They're still logged in. They're still active in our system. I'm going to issue a new JWT. And it's hard to see on the screen, but that orange JWT is now JWT prime, right? And that gets passed down to the client, who can replace the JWT that it currently has. And then it can pass that JWT prime to the to-do API. And that JWT prime has a new expiration time, right? It's 5 more minutes of time. And then you can go back and get the data. And so that is what the refresh token grant lets you do. It lets you have a JWT and get the access, that stateless access, but if it lets you make the JWT lifetime short and lets you basically re-authenticate the user without the user having to retype in their credentials. If we're talking about logout in a JWT-based session, then we're talking about revoking the refresh token. Dimitri, I see your question. I'm gonna answer in a second. I just want to do this. So for logout, basically the client passes the refresh token up to the user API, says, please revoke this refresh token, and then it deletes the refresh token and the JWT from itself. So that is pretty much what you get for logout in a JWT-based system. So for Dimitri, he says, can you please explain one more time the role of the issuer like FusionAuth in your example? Are you talking about the refresh token example? Or just in general, like in this architecture? The JWT token, great, yes. So in this situation, the user API is generating the JWT, and FusionAuth can be a user API. There are open source libraries that can generate JWTs that can be the user API. I think Spring might be able to generate them. So the whole point is that this user API takes care of authenticating the user and then issuing the JWT. It's probably not calling out to somebody else to issue a JWT. It's probably doing that itself. Oh, great. Thanks, Peter.
Hey folks, yeah, I just wanted to let you know that I just set it so that everyone could unmute themselves if we get into more conversation, probably a little more efficient than chat.
Sure.
So you're welcome to unmute yourself and chat at this point. Thanks for being patient. Sorry, we just had a kind of a bad Zoom bomb a few sessions ago, so we're a little bit cautious. Appreciate your patience.
Cool. Great question, Dimitri. All right. So we were talking about logout. We're wrapping up here. So we're talking about revocation real quick. This is typically a pretty common question. People say, hey, I have a situation where I want to revoke a JWT, and it's for security issues, right? Like if someone's account is compromised or something like that, we want to be able to immediately invalidate their JWTs. And I've noticed this is already a question. Part of this is being recorded. Yep. So, and it'll be on the YouTube, the SFJUG YouTube. So your options are, you can rotate the signing keys, which obviously is going to invalidate all of the JWTs that are signed with that key. You can have really short lifetimes, which really don't give you true revocation, but they might lower the threat model, right? Like if your JWT's only good for 5 seconds, if someone somehow gets access to a JWT, they may not be able to do that much damage in 5 seconds. The other option is what we call deny list. And so this is not standardized, by the way. I don't know what other providers do this, but I know that there are some libraries out there that support this kind of pattern. So basically, when someone logs out, the user API fires or if they log out, or if for whatever other reason, we might revoke their refresh token, right? And that is essentially a logout event. That is a way to say, hey, this user is no longer kind of active in this application anymore. Then FusionAuth fires what we call a refresh token revoke event that can be caught by the to-do API and any other APIs, and then stored off. And then if someone were to present, and that has information about the user and the date that it happened, if someone were to present a JWT that was tied to that user, the to-do API could, in addition to checking the signature, checking the issuer, checking the audience, checking the expiration time, it could look and say, oh, is this JWT associated with a user that has been logged out? And if that is true, then I'm going to treat this JWT as invalid, just as if it had expired. And so this is a trade-off, because obviously you're pushing state back into the to-do API. The to-do API has to have more information than it, and it's not truly totally separate from the user API because it's listening for that webhook, but that gives you a way to like revoke a JWT quickly because you're kind of pushing that state about the status of the jot out. So concluding real quick, here's additional information. Time for more questions. We have a jot debugger. The example code I mentioned is right here on the second line. I will get Peter the slides as a PDF so that he can post them on the meetup, or maybe I'll do that myself.
We'll link them. Yeah, you can do that, Dan. And I'll also, if you give me the URL, I'll link to it in the YouTube video replay description.
Awesome. Perfect. Great.
Yep.
Well, I'll make sure to do that so that you don't have to take a snapshot of these URLs, right? The fourth and fifth points right here are basically a couple of essays I've written. It's if you want to read 7,000 words about how to build a jot or how to look at like the pieces of a jot, those articles are your jam. The last point right here is that you can download FusionAuth and run it yourself for free. We have a community edition that is full featured. So if you want to kick the tires on OAuth or OIDC, just want to explore it, you can download it with a Docker or a zip file, RPM, whatever.